Welcome everybody, good morning. I would like to give my talk about the biophilia, the relationship of man and nature. First of all, I would like to say a little bit about myself, although I was already properly introduced, but it's in the presentation. My name is Kas Houthuijs, and this am I, I have a background in biomedical sciences and neuroscience. And now I work at the HKU, the School of Arts here in Utrecht, and also work in the Waag in Amsterdam at the Biohack Academy and the Hybrid Lab Network. So first I was more of the science part, and now I'm changing a little bit into more of the arts and design regions. So what is biophilia? I think for most of you and for most of the people it's a new term, or it's a little bit strange term. And if we dissect it literally, it's bio, life, and philia, love. So love for nature. But it's more than that. It was coined by Edward Wilson as the urge to affiliate with other forms of life. And is that a little bit of tree hugging? Well, yeah, it could be. But I think there are many ways to show our relationship with nature. And that could be through conservation, architecture, or technology. And today I would like to take you on a 20-minute tour through the journey of mankind. I would like to show our relationship with nature and technology, and I will show you a glimpse of the future and a choice that every human being has to make rather soon. So this is the way most people have seen our humankind in nature. Man as top of the food chain. There are many creation myths where the whole world was created just for us. And we are the end product of millions of years of evolution. And to be fair, it's not really our fault that we look at it this way. We are the only ones who can ask these questions. We are the only ones who can stand here and give a presentation. We are the only ones who can tune in for this presentation. But maybe a little bit of humility is not a bad thing, because we are not the end point of evolution. Other species are not less advanced than we are. Every species that is living right now has had the exact same length of evolutionary history. They only have different selection pressures. We, as humans, try to distance ourselves from nature. We try to shape our environment to the needs of us and to create a barrier between us and the civilizations, between our civilization and the wild. But somehow we feel that it's not correct to really distance ourselves from nature. And I think this shows beautifully in the fact that in 2020, a moldy burger was one of the prize-winning advertisements for a fast food chain to show that what you eat there is still natural. And maybe even more strongly, while we're living in a pandemic, we cannot keep the natural world outside. It's simply not possible. So maybe this is more like it. Maybe this is more how we should view the world. We are part of life, a piece of in a network of interdependent life forms. And we share our planet with countless other species. However, if we zoom out a little bit and we look at the planet from an alien point of view, if you were visiting Earth, who would you think is the most dominant species? Would it be humans, with our great planets and the way we stretch and we change the environments? Or would it be plants? We call it the green planet. Or maybe insects. There are plenty of insects all on all different places, stronger than us. I don't think so. I would like to make a point that it will be a microorganism. And which one? I have no idea myself. It might even be that it's one that we haven't discovered yet. So if we dive into the world of microorganisms, 60% of all the biomass in the world is made up of microorganisms. So all the animals, all the plants, all the humans, all the insects, all the fish in the sea, everything combined is still 40% of all the mass, living mass in the world. Almost the rest, everything, 60% is microorganism. Also, 50% of our oxygen is created by microorganisms. That's not the trees. We talk about the Amazon being the lungs of the earth. And I would not advocate not trying to preserve the Amazon forest. But if you make the case that it's because of the oxygen, it's simply not true. Most of the oxygen is created by the microorganisms, or at least, even if you look at the forests, the Amazon is not even the biggest one. So if we look at it underground, all life is directly dependent on microorganisms. So in a way, we do live in a world called microbia. And I think that's beautifully shown in the work by Sasha Spachal, Earthlink, which shows it's based on 3 different installations put together: inspiration, exploration, and the symbiome, where they work together as an intricate network of bacteria, fungi, plants, and us. Inspiration is where you inhale air which has been enhanced by soil bacteria to improve your mood, reduce anxiety, and increase mental capacity. You can think of it as the smell of rain on a hot summer's day, or when you walk into a forest and you feel like forest bathing. Then there's, expiration. You disperse bacteria by breathing out, and they grow onto different soils. And when you exhale, they grow and they show the impact of us on nature. Furthermore, the symbiome, the interdependence of bacteria and plants. They trade nitrogen for food. And altogether they form this earth link. Also, if we look at the tree of life, this is our most comprehensive tree of life up to date. We have this is based on whole genome sequences, and this is all of life that we know. So first, if we look at humans, we're here, where the arrow is pointing. And then if we look at fish, we came from the oceans. Where would that be? It's actually right next to it. Trees, much older, you think? Well, not that much older. They're also right next door. And the first microorganisms, thinking of fungi, they're even in between. We are more closely related to fungi than we are to plants. And all the rest is all microorganisms. They're all the blue is bacteria. And all the orange is archaea, which is actually more similar, very similar to bacteria. So all of what we think of as life or as nature normally, it's just being comprised of this very small point here. And most of what we don't see, we don't even contemplate it as life. So it's a little bit arrogant from us to think of as being the top of the food chain and being most important things in life. And maybe if you look at the time scale of Earth, you'll see, because it's impossible to grasp the millions of years on which the Earth has been here. 4.5 billion years. But if you put it in 1 year, so the 1st of January is when the Earth was formed, then in the first life became about 1st of January. And then for almost all of the year, until the 15th of November, you find only single-celled organisms. 15th of November, multicellular life began, and 15th of December, we crawled out of the water. And only the last half hour, mankind has emerged on the stage. And that's half an hour, but when you think of all of our history, what we call history is everything in the last minute. The cultivation of plants and animals as agriculture, the changing of our environments where we started living in cities and living together, and the invention of writing to communicate via symbolism, that's all in the last minute. So once again, we are very late at the party and then stating very loudly that we are the ones who are the most important ones at the party. If we zoom in a little bit, this is the most detailed image and anatomically correct illustration of the human cell at the moment. It was this year. And we show on this side you see the nucleus, so the core of the cell with all the DNA and the information. The membranes, where 2 cells are communicating with each other. And this is a mitochondrium. A mitochondria is the powerhouse of the cell. It drives the energy. And when you see this, it's actually very interesting because this used to be a different bacteria. There used to be 2 different bacteria where one ate the other and they stayed alive and stayed inside each other. So a mitochondria was a bacteria which came to live inside a cell. And now it's evolved to be part of our cells. And this is not a very specific thing. No, no, no. This happened multiple times. The fact that plants all around me here are green has the same region. It's also the same thing, because chloroplasts are also, they used to be specific individual bacteria, and now they have changed into a part of the cell. And there are algae where this fact happened 4 times. Like every time it was eaten by another and kept living, and they started living together as symbiosis. And we live together with microorganisms all the time. When you look at us, we're almost half microbe. When you check our cells, we're half microbe. Just half of it is our cells, the other half of the number of cells is microbes. And some of them just pass through, some of them can harm us, but many actually benefit us. And they evolve to work together. And we evolve to work together with them. So we need to keep each other healthy, because they break down fibers that we cannot break down ourselves. They make crucial molecules like vitamins, amino acids, hormones, and they even train our immune system to help us. And we also need to take care of them, because we get our microbiome from our mothers through the birth canal. And people who've been born with via C-section have a higher chance of specific disease, specifically asthma or allergies, by not training our immune system properly. And also, what I find very cute is that mother milk has specific sugars that we ourselves cannot use. They're useless to us, but they are specifically there to feed our young microbiome. So mother milk is also directly feeding your microbiome. And there are more diseases which have linked with unhealthy microbiome. Depression, schizophrenia, and one of the first symptoms of Parkinson's disease is digestive problems. This is a very new field, and all these things are just barely being scratched, but this is a very new scientific research field. And they're actually testing, if you have the wrong type of microbiome, you can have a poop transplantation. I'm not joking, that's really a thing, and that's happening right now. So it's important to understand that we and our microbiome have evolved to work together, and we cannot live without each other. So what is the microbiome? The collection of all the microorganisms in and around us. And the work of Pim Borrell in the BioID lab shows it. It's very specific and unique per person, and it shows the microbiome on your face. These are face masks. And it's unique, and it differs per moment. It's like a picture. It's a picture that's being taken at you at the moment. So we live in symbiosis, and we need to work together. But we can design to help our microbiome help us, because it goes further. Recent studies have shown that what you eat will feed the bacteria inside you. Okay, so far so good. But also that they trick us into eating specific foods. So for example, if you eat more fatty foods, you grow more bacteria inside your gut that feed on fatty foods, and they trick your brain into wanting more fatty foods. So you get into some sort of vicious cycle. But on the other hand, it also works the other way. If you eat more leafy greens, your bacteria in your gut also, you grow more specific bacteria that love the leafy greens, and you want to eat more leafy greens. So it's like a garden, and you need to tend the microbiome inside your body like a garden. And designing with microorganisms, it's not a new thing. It's actually really old. In agriculture, the Native Americans already found that if you plant 3 different crops together, corn, squash, and beans, you have the 3 sisters method where they all benefit from each other. The corn can provide a scaffold for the beans provide nitrogen in the soil, and the squash prevents weeds and animals from eating all 3. So they work together, and all are needed. And also, fermentation. Fermentation is one of the oldest methods of preserving food. And what I really like is there are hypotheses that claim that agriculture was actually invented to keep up with the demand for alcoholic beverage. I don't know how true that is, but with the Christmas days coming, it's worth reconsidering that. It might actually be. So the top one, Auspicio, is actually so simple, but it's brilliant. On the water lock, they placed a very small communication flute from indigenous tribes. And so the different pots are communicating with each other through the exhaling of the microorganisms. If you have time, please check this out because it's really funny. The sound. Maybe we can put it in the chat later. And also the spoiled spores, which is very interesting, where Avril Caroon made cheeses from the molds in slumlord houses from student housing. So she wanted to make the problems with student housing, how moldy and how bad they were, and that she made cheeses with the different molds that she found in the different houses. And well, how funny and interesting that might be, these ways of using microorganisms and using nature in our advantage, that is our evolution. Using that technology, using that knowledge is our evolution. So if we look at the most important things that we as humans did, first of all, of course, there's fire. When we tamed fire 2 million years ago, we weren't even human. The humankind exists only roughly 300,000 years, but before we tamed fire as a precursor and as humans, and we started to create a barrier, drive a wedge between us and other animals. Second most important thing, agriculture. And this really changed the game for humans around 12,000 years ago. Because it was the invention of possession and the need to protect that possession and to count that possession. And it was invented, among other places, among the Fertile Crescent, which is present-day Persian Gulf, Middle East, in Mesopotamia. And this iconic bullhead mask is from Dilmun. It's from that region. And actually, Dilmun was the inspiration for the Garden of Eden in the Bible. And I would pose that there's a third, and that's coming up right now, and that's genetic modification. Genetic modification or genetic engineering, we are stepping over the doorstep, and I would like to take you with me. I'd like to take you with me on this journey and look into what might lie ahead. So, as I'm saying, we are stepping already over it, because it's not new. We've been doing genetic engineering since the 70s. And in the beginning, it was very successful, because we are protecting crops from diseases, manipulating microorganisms to produce medicine, fuel. Right now, if people are using insulin for diabetes, almost 100% they're getting it from a GMO algae, because they don't get it from anything else anymore. I think the major problem was because it was done behind closed doors. And Eduardo Koch showed this with Alba. He created a GFP, a green fluorescent protein rabbit. Green fluorescent protein is a protein which derives from a jellyfish, and they transpose it into a lot of different animals for research. But it was happened behind closed doors, and when he did it into a rabbit not for scientific purposes, but for artistic purposes, it was a very big controversy. But I think the biggest problem is that it's misused to create more money and more power. By far the most GMO work has been done into getting resistance to pesticides and herbicides. And I think most of you might know the names of Monsanto or Roundup, in which they made crops resistant to herbicides so they could use more herbicides and sell more herbicides, which is ridiculous. So that created a very bad name for GMOs. Although it's not all bad, because as I stated, medical science cannot do without GMOs, cannot do without this new technology. And what you show here is a slice of the brain in which all cells are colored differently with coloring. And those are GMOs. But also, Salk is a company which using the Harnessing Plants initiative, where they make changes, genetic changes to plants to grow more roots and deeper roots and stronger roots, so they can put more carbon into the soil, and also to make the soil more permeable to water, so to help to fight desertification and to increase nutritional value. And also what I find interesting is Dan Barber, who is advocating using GMOs to enhance the flavor of food, so create new flavors and better flavors. And then the next step to making genetic enhancements into ourselves. It's not really a big step. And is that science fiction? Well, unfortunately not. In 2018, this Chinese scientist made a genetic alteration in the twins Lulu and Nana, and he changed them to be immune to HIV. Not a bad thing, you might say, but the world is definitely not ready for that. And the question is, should we be ready for that? Because there was a big scientific outbreak, but international outcry as well, and he is now in jail. This was done through a new technique, and this is called the CRISPR-Cas9 technique. You may have heard about it, you may have not heard about it, but this is going to be a very big changer. And actually, Emmanuelle Charpentier and Jennifer Doudna won the Nobel Prize of Chemistry this year for this discovery. And this is so big because it makes it so easy to change, to genetically engineer DNA. And that's what the Return to Dilmun work shows. This is actually a picture where they converted the picture to DNA and then did some sort of Photoshop on the DNA. So they altered the eyes, they put the eyes in, but not in the picture, but by changing the DNA which encoded the picture. And this could be done in almost any lab. This was outside of a cell, this was just by pipetting, and this was done in the Waag, and it shows how easy it can be done by almost everybody. And that's the danger. It's becoming very cheap and very easy to do this, and it's already possible. So if we are going to do this, is it going to go this fast? But think of it this way. In July 1978, it was a very big scandal. The first person who was born through IVF. And that was 40 years ago. Right now, 1 in 30 children in the Netherlands is being born through IVF. 1 in 30. So I don't know how many people are watching right now, but it's probably 1 in 30. And that's the thing. It's so normal. Right now, we do not think of someone who's born through IVF or thinking about doing IVF that it's strange or that's weird or that they shouldn't be considered real humans. That was the case 40 years ago. So in 40 years ago, where will we stand? And we already are crossing this threshold. So my question to you is, what do you want to do with this new technology? Are we letting a few companies run away with it, like Monsanto did with the GMOs in crops? Or are we going to use this technology for good and for the planet? I feel this is the next step in our evolution. And we could use it for a better world, or we can let a few people get more power and just get richer. And I feel more people should know about this, and more people should talk about this. And that's why I helped create the Baby Builder with Bertrand Burgers. And this was actually design your own baby. And it was challenge people to think about their values, about life, and how it works and the friction it creates between parenthood. Because everybody wants the best thing for their child. So would you give your child immunity to specific diseases? Well, maybe. Would you give it stronger bones and stronger heart, or make it a little smarter than average? But would you decide also your sexual orientation of your child because it was maybe easier in life, or other personality traits? Where do you draw the line? And I think that that's a very important question. And it was on the Dutch Design Week this year. Unfortunately, no one could watch it, but it was there. And I feel that this is very, very important to talk about this. So to recap this, I would say we are living in symbiosis with nature, and that's not a new thing. We are the result of millions of years of evolution in collaboration. And we cannot survive without our microbiome, so we need to tend to our inner garden. Also, we as humans, technology is our evolution. We are not strong or are poisonous, have strong fangs or dangerous teeth. Our strength lies in using technology and collaborating with each other. But with technology also comes a big price, because we need to, with that power, we have the responsibility to use it correctly. But the dangerous thing is to be afraid of new technologies, and we shouldn't be. Because the technology itself is not a bad thing, it's how it's used. And genetic engineering is just the next step in designing with nature. And by looking away, we will only give power to a few who will use it for their own benefit. So we shouldn't look away. But I do hope that we will design together with the world. And not just for ourselves, but also after your time. So this is a really cool thing. Thank you very much.